I discussed briefly the Fourier synthesis equation for even functions. The primary property of Fourier series for even functions is that the final sum consists only of the cosine terms. The reason for that follows from the properties of even and odd functions. So what you need to know is that an even function times an even function is even, an odd times an odd function is even, and an even function times an odd function is actually odd. So when you think about the Fourier analysis integral for some even function x of t, what you'll get is that when you integrate over one period is that the odd integrals go to 0. So here's the sine integral part. Sine is an odd function multiplied by an even function. You get an odd function, and in the end, all of the b sub k terms, the sine terms, will actually go to 0. And in the end, you only need to calculate the cosine terms. That's really all you need to know about that. And I'm going to take a brief example here with, let's say, f of x equals x squared, which is obviously an even function. And this is not a periodic function by design, but you can take its periodic extension from, let's say I'm interested in the Fourier series on negative pi to pi. I'm going to form its periodic extension on the whole line, and you'll see here from negative 5 pi to 5 pi, where its actual period is 2 pi. Now, to see this, let's see the Fourier series, and I'll show you the result for 5 terms, 10 terms, and 50 terms. And the graphs are actually very close here. You'll see there's just a little bit of error here, and it'll get slightly better. It's hard to see. And again, what you'll see is that increasing terms of the Fourier series improves the approximation, and 2, the approximation is actually mostly worse near the endpoint where you form the periodic extension. Lastly, you'll see that the Fourier coefficients here is not the sine terms, but it's the cosine terms, and you'll see that the coefficients will decay. All the later harmonics go to 0, and the early harmonics had the most contribution. That would be all.